Here we are with week 22 maintenance for the Pure Maths 1 course. Quadratics question first. We've got to solve this inequality. I'm going to expand my brackets on the left hand side. Then I'm going to bring the right hand side over to the left hand side. So I've got 0 on the right hand side. Now I gather all my like terms. I get x squared minus 3x, I guess, and then I've got, what's that, plus 10, plus 10 is greater than 0. So I guess I need to now factorize, so this will be x minus 5, bracket x plus 2 is greater than 0, and if we just do a quick sketch, we've got a root here at 5, and we've got a root at minus 2, and we want greater than 0, so we want here and here. So x is either less than minus 3 or x is greater than 5. Now moving on, the next one, we've got this function, and we've got to express it in a completed square form. So I will first of all factorize that the 4 out to make this. Then I will now, within the square bracket, complete the square. So it'll be x minus 3 all squared, subtract 9, close the square bracket, plus 11. Now I can expand that 4, so I get 4 bracket x minus 3 all squared, minus 36 plus 11, and you can see that this will give me 4 bracket x minus 3 all squared, minus 25. So therefore the vertex of the minimum point are at 3, 25. Okay, 3, 25. Now we want to know the function g, which we've just done. Oh yes, we've got a domain here. Is x is less than or equal to 1. This will be equal to 1. I guess what we'll do is we'll, well, we know less than or equal to 1. Here's 1 here. So everything's going to be higher than that point there. So if we go g1 equals, what do we get for g1? I think we get negative 9. And therefore gx oh, sorry, that's negative 20. I'm like just having a mind block here, because like, how can it be negative 9 when we've got a 25 here? That's negative 25. Okay, so I should have a negative 25 there. Sorry team. Wake up, Mr. K. Okay, so gx is greater than or equal to negative 9 if the range is less than or equal to 1. Now we've got to find a expression for the inverse. So you always want to use your completed square version here. So we're going to do this. I'm going to swap my x and y values over. So I should get this. And then I'm going to pull that 25 across. And then I'm going to divide by 4 to leave me with y minus 3 all squared on this side. And then I'll take the square root. So I get y minus 3 equals plus or minus the square root of x plus 25 all over 4. And we can say y is equal to 3 plus or minus the square root of x plus 25 over 4. Now, I'm going to write that in the function notation. And because we're on the left-hand side of the vertex, this is on the left-hand side, we want the 3 minus the square root of x plus 25 all over 4. Well, there we go. Oh wait, we need to state the domain. So the domain of the inverse is equal to the range of the original. Now, the range that we had here is now our domain, so for x is greater than or equal to -9. Okay, well that's us on that one. Let's move on to the coordinate geometry question. We've got a line and another line, which is perpendicular to the first line. Okay, so what I'm going to do is I'm going to rewrite this as 5y equals -2x plus 10, and I'll write it as y equals -2/5 x plus 2. Now, therefore, if line 2's gradient it must be perpendicular because it's perpendicular to line L1. So gradient is a negative reciprocal of this -2/5, so 5/2. And now, because we know a coordinate on that line, we can just use y minus y1. So y minus -6 equals m into x minus -9. And m, of course, is 5/2, so I'll just pop that in as well. And so we get y plus 6 equals 5/2 x plus 9 plus 9, so 35/2. Now we can just take that 6 away, so y equals 5/2 x, and then if we're taking 6 away, that's like 12. Oh, hang on, did I say 5 9s are 45, not 35? Gee, look, wake up brain, 45. And then we're going to take, so we've got 45/2, and we're going to subtract that 6, which is 12/2, so we subtract that, and so you get y is equal to 5/2 x minus 30 plus 33/2. I think that's the answer. Okay. The next one, given that the lines L1 and L2 intersect at point B, find the area of the triangle ABO where O is the origin. Okay. Well, we probably want to find where they intersect, I guess, first. So we'll go minus 2/5 x plus 2 equals 5/2 x plus 33/2, and I guess we can bring everything, what do we get? I'll pull the 33/2 across, so I get negative 29/2 equals, I'll bring the x across the other side, 29/10x. So x is equal to -5. And therefore y is equal to, I just chuck that into my formula, and I'm getting, let's see, that would be -2, so positive, I think it's 4. So that's where those two lines meet. Okay, so now let's just have a quick think about what we're trying to achieve here. We've got this triangle. We know that there's point A. So I've got line 1. This is line 1 up here. And it crosses at, say, 2. And it's got a negative gradient. So let's just say it's something like this, okay? So that's line 1. Then we've got line 2, which is this one we've just figured out here. And so this one is at -9, -6. So it's perpendicular to that one, and they meet at A. So we'll say this is A. Oh, sorry, that's B. That's where they meet. This is A here. And they want us to find ABO, where O is the origin. Whoops. And so the origin is here. Now we've got to find the area of this triangle. There's a couple ways of doing it. I'm going to split it, I think, into two triangles. This one, pink one, and the green one, and go half base times height for each of them. So you can see the height here is, what do we say that was? Where do they meet? At B. So this is 4. Now for this one, the height to here is, where's A? -6, so it's 6. And then we just need to find this base here for both triangles. Okay, so we need to find out where this is. So I'm going to use, I'm going to find line AB. So gradient AB. Oh, hang on. I already know what line AB is. So that's this here, isn't it? This is line AB. So I'm going to find out where it crosses the x-axis, which is where y equals 0. So 0 equals 5 over 2 x plus 33 over 2. And I'm just going to rearrange that. And I get 5 over 2 x equals negative 33 over 2. And so 5x equals negative 33. So x equals negative 33 over 5 equals negative 6.6. Okay. So we know that the base is negative 6.6 or 6.6. So triangle, pink triangle is equal to half times 6.6 times the height, and then green triangle equals half 6.6 times the height, and then we sum them together, and I'm getting 33, I think. Yeah, 33. Okay, perfect. Oh, yeah, of course. All right, now let's move on. Yes, so this next one is a circular measure question. And what we're trying to do here is we've got this circle that's touching with a center O and a radius, and a circle with center C and radius X lies within the sector and touches at PQR, and angle POR is 1.2 radians, and we've got to show that X is equal to 7.218 correct to 3 decimal places. Okay, so probably what I would do is I would maybe split this right down the middle here, and I would find out maybe I could use OC. Make a triangle out of it, I think. So I'm going to go sine 0.6 equals x over OC. My first go, so you can see I've split it into a triangle like this. It's a right angled triangle because there's a tangent there, isn't it? And so I'll say that OC is equal to x over sine 0.6 and I know that OC plus x should be equal to 20. Why do I know that? Well, because the radius of the bigger circle there is 20. Now, therefore, I can say that x over sine 0.6, of course we're in radians here, plus x equals 20. And then I can solve for x. So when I solve for x, I'm getting x is equal to 7.218. Find the total area of the 3 parts of the sector lying outside the circle. Okay, so we're wanting this bit here, and this bit here. Well, I guess what we're doing is we're going area equals the half r squared theta, which is the sector area. So that would give me the whole thing. Then I've got to subtract the circle. So pi times r squared. Now, r squared is this. And when I plug that in to my calculator, I got 76.3 centimeters squared. The next one is an identity from trigonometry, and probably what I'm going to do is rewrite it first as cosine over sine over cosine into 1 plus sine theta, and I can next write that as cosine squared theta over sine theta into 1 plus sine theta. So some of you might be like, oh, how did you do that? Well, we've got this divided by this fraction, so this one is like flipping and timesing. Remember your basic fractions rules there. So we got cosine squared theta, and I'm going to expand that bracket on the bottom to get sine theta plus sine squared theta. And then I'm going to rewrite the top as 1 minus sine squared theta, and I'll put that over sine theta into 1 plus sine theta, and then hopefully you can see that this is the difference between two squares, so I could rewrite this as 1 minus sine theta, and this will be 1 plus sine theta, which will help me eliminate on the bottom my 1 plus sine theta. So that will get rid of that, and therefore that will leave me with 1 over sine theta minus sine theta over sine theta, and of course that's 1 over sine theta minus 1, which is exactly what we wanted to get. And it says hence solve this equation. So now we're just going to go 1 over sine theta minus 1 equals 1. So we get 1 over sine theta equals 2, and therefore sine theta equals 1 over 2. So theta equals the inverse sine of 1 over 2. And therefore theta is equal to 30 degrees. And of course by symmetry, we've got another one over here. So that's 150 degrees. Now, we've got a series question here. It's a geometric progression. All the terms are positive. The second term is 24, and the fourth term is 13.5. So we know that AR is 24. We know that AR cubed is 13.5. And therefore we know that R squared is equal to 13.5 over 24. And therefore R is equal to the square root of that, which is 3/4. And therefore A equals 24 times 4 over 3, which is 32. Okay. now the sum to infinity of the progression. So remember our sum to infinity, this is one of the formulae that you get on your formula sheet, is a over 1 minus r, and we can chuck in now 32 over 1 minus 3/4, and it's a bit messy, right neatly, eh? And this is giving me 1/4, 4 3s, so 420, 128 is our answer there. Okie dokie, the differentiation question for this week, we've got a line, it's a tangent to this curve, and we've got to find the value of k. Okay, so first of all, I'm going to rewrite this as y equals x squared over 4, and therefore we can now jump right into the question. So we're going to have x over k plus k equals x squared over 4. I'm going to multiply everything by 4. No, I'm not. I'm just going to write it as 1 over 1/4 x squared minus x over k minus k equals 0. And if it's a tangent, we know that b squared minus 4ac equals 0. That means b squared, which is negative 1 over k squared minus 4 times a, 1/4, times c, negative k, equals 0. So we should get 1 over k squared plus k equals 0. And at this point, I'll go 1 over k squared equals negative k, and so I'll get 1 equals negative k cubed, so I get k cubed equals negative 1, and so k equals negative 1. Oh yeah, that wasn't so hard, was it? Now the next one, I'm trying to find the coordinates of P where it is the tangent to the curve. So I will take, so I'll take this here and I'll put in those values of k. So I'll have 1/4, whoopsie, 1/4 x squared minus x over minus 1, so that's plus x, plus 1 equals 0. And so if I multiply everything by 4, I get x squared plus 4x plus 4 equals 0. And that to me looks like I can just factorize it. X plus 2 all squared equals 0. So x equals minus 2. Therefore, y equals what will y equal? So we need to chuck that into, maybe we'll chuck it into the line here, which of course the line would be y equals negative x minus 1. So if we chuck in our value of negative 2, so we get 2 minus 1. So 1, I think y is equal to 1. So minus 2 comma 1, I think. Oh, don't know what happened there. Should be the coordinates of P, where the tangent occurs. Alright, well I hope that makes sense to you all. Let me know if there's any questions or queries, or if I've made a mistake that you've spotted. That would be helpful. Alright, take care. God bless.